Hello and welcome to this TGA digital video on how to do triplanar texture mapping using ShaderFX in Autodesk Maya. This way of placing textures doesn't utilize the regular UV coordinates. Instead, you use the XYZ direction of the 3D space to place the textures. If you're not familiar with working with ShaderFX for Maya, check out the link in the description below for a video where I show you how to get started. So, let's get started building this shader. In this lesson, we'll look at a texturing method called Triplanar Projection. And this is what you get when you're doing Triplanar Projection. What that means is we're not using any UV set of the model here. We're actually projecting the texture from this direction, and also from above, like this direction. So depending on which angle the polygon face is aiming or facing towards, it gets that certain projection. And the neat thing about this is you can use it for a few benefits as I see it. You can use it for especially when you're doing terrain or landscape for games. You might be projecting the texture from seen from above. And you usually use this technique to cover where you have hills or mountains or such where you have a steep lean angle. Because if you imagine if you're just projecting the texture from above, you get texture stretching as the faces will lean away from the projected direction, if you will. So that's one thing you can use this kind of shading for. Another thing is you can use this as a quick base when you're going to texture something. So let's say that I was doing some environment piece or whatever kind of texture where I wanted some baseline texture or structure or similar. You can use this shader, apply the texture that you want, set the tiling parameters to whatever you need. You can also set this transition sharpness value, and then you can go ahead and bake the texture to get this kind of result. Now this here is the character's UV set, and the shader has now been transferred, the results from the shader to the UV set as an actual texture, which is cool. So, are there any seams? Well, yes, of course there are. I mean, if they're not that visible or possible for you to see at first glimpse, then I suppose that the shading is working out nice in that sense. But just to show you how it works, I think I'll go ahead and just change the tiling a bit. And at locations where the angle starts leaning more towards another direction, such as here we get from above, on the neck we get from the side, and where they meet around here, you can see that you have this fading area where you have one leaf fading into another one. And I have this transition sharpness to be able to set this. So a low value such as 1, for instance, will give a really wide sharpness area, and as I increase this value, you'll see that this transition starts to get more sharp. And I can even type in a larger value here just to show you. Here you've got this really sharp edge, and also here. Same with the head, for instance. Up here we have the transition area between this face and this one, and same along this edge here. So we can set it back to, let's say, 10 or something, and I can just show you, for instance, the gravel texture, just to show you a different texture. And as you'll see, this is based on how the model is moved or rotated in space, so it has this kind of funky effect as you move it around. And that is because the base of this is, we don't use any UV map for the character, at least not when projecting the textures. Instead, we use the vertex point's world space position. So where this vertex point is located in world space, we'll use that as our UV coordinates. So for the projection along this axis, when we're looking down this way, we'll use the X direction. That is, each vertex point's X position will be similar to what the U direction would be in the UV editor, and the Y position of the vertices would represent the V direction in the UV editor. So we'll use those two values for this projection. Same with this projection, we use the Z for U and Y for V, and from here we would use the X for U and let's see, Z for V direction. Yep. You'd also need some way to decide where does each of these three projections come from, and we'll use the polygons normal, the world normal of the polygons, to choose which of these three projections we'll be using. So let's get started with ShaderFX. I'll go ahead and assign a new material and choose ShaderFX shader. I'll open my shader and I'll make sure that I'm in advanced mode, which lets me delete this starting node, the traditional game surface shader. I will go ahead and use my baseline shader group, which we created earlier in these lessons. And if you've not followed along, these are just the 5 core nodes that you need to display any kind of color out on the model. So let's start with just adding a texture to work with. And I almost forgot, but the head model here is the one of Lee Perry Smith, which he shared with the 3D community for royalty-free usage. So thank you very much for sharing this with the 3D community. And the textures I've used are from CG Textures. So let's choose a texture. I've created a texture map and I'll be pointing towards which texture I want to use. Let's say the gravel special here again, and we'll connect that as our color. That's what we get, and we can start tiling it and projecting it from the right direction. But as you can see here, we've got some stretching going on, and that is because of how the UV works. The UV as well isn't connected here, so we get this large seam all the way here. Yep. So to project this from a certain direction in world space, we'll use the vertex world position, this one. This node is going to give us the positional value for each vertex point we get here in XYZ. So let's say that we want to project it looking straight at the guy here. So we'll use the Y and X values for our U and V. So X will be U and Y will be V, yeah. And I get a float 3 here, which is going to contain X, Y and Z, and I just want the X and the Y. So I need to use a vector component to be able to access these two. And I'll connect the XYZ into here. And yep, X and Y, I'm just making sure. So I should be able to use this one, right? Let's see how that works. If I connect this one here and have a look, it seems to be working right, and we get this nasty stretching here, but that's anticipated, since this one should only look correct, if you will, viewing down this angle. And this is the result you get from Maya as well if you went for UV and a planar mapping from this direction. And this is what we're trying to avoid. This is also the kind of look you would get on your terrain if you had very steep hills or mountains and you just projected a texture from above. So next step is to be able to project from 3 different directions. And one thing that I've learned that you need to do, and it will get back at you in the end if you don't do this, and that is when we're finishing up our shader, we want to expose the relevant variables or parameters for the end user to be able to change in the shader. And since we need 3 different projections, we need 3 of the texture samplers in here. We can't just do all of the projections into the same texture map node. And the problem with copy and pasting this node like so is that we have to expose all of these 3 as individual input parameters. And in the end shader that the user would use, you'd had 3 different texture slots, even though you would use the same texture. And to me that doesn't sound appealing. It's not intuitive or nice. So one way to get around this is that we'll modify how this one works. As I've mentioned earlier with groups, if we're going to be editing this and want to save the changes, the edits we do, we need to make sure that this is not a reference pointing towards the group on the disk on the computer. So we'll select the node and go make group unique, which makes sure that this exact group and everything within it will be saved to the file and not just a reference. Now if we go inside here and have a look, you've got all of these nodes, and the key node that we want to access here is the My Texture node. Over here at the left, if you see the network, the My Texture. And the reason we want this node is because this is the key node that is going to hold the path of the texture and the node that you're actually exposing for the end user. So what we want to do, the plan here is to take My Texture node, place it outside here, and then have 3 texture samplers and have the same My Texture feeding into these. So we only get one texture path here in the end. So the way to do this is we're going to need to take this node and place it outside of the group. And since I have one other node on the left side connecting into the My Texture, I'll need to extract this one as well. But these are the 2 most left nodes in this network. So the way you would do this is, for instance, I need the texture outputting from here, and I need the texture type. So I'll go from one of these textures, this one or this one, and I'll drag from here and connect it to one of these 3 input connections here. Right, so give me some weird error here in Maya, and I think that might be because I'm not feeding anything into this one yet, but I will fix that in the end. Oddly enough, I did not get this error message before, but I think we're fine. So now this node, the sampler state, gets its texture from outside here and not from this one. So now we can go from here and connect to here and make sure that these 2 nodes are not relying on the texture connection from this one. Same with this one. I've got this texture type which is feeding into the sampler node, the sampler state and the texture sampler. So I'll connect the texture type to another one of these 3 inputs and then go from here and connect it over here. And now I've made sure that none of these 2 nodes are actually connected now. Now be aware, I think I've mentioned this before, but you don't want to cut in ShaderFX. You can't go Ctrl X to cut, because that would close down the shader editor and it would cut out the entire shader node in Maya, and you'd get an orange result here, I think. So you can use Control C and V for copy paste, but don't use cut. So I'm going to copy these 2 and place them outside here. I'll go ahead and connect the texture into the texture here and the texture type into the texture type. And let's just make sure that, yeah, we're getting the correct results. I'll also just go inside here and I can go ahead and delete these since I've already copied them and I have them outside now. Now we can go ahead and copy this one 3 times. So 1, 2, or actually not copy 3 times, I want 3 copies. And now we can use the same texture here going into all of these, like so, and the texture type here going in here. And now as we select the My Texture node, I can go expose as material input and call it, let's call it tiling texture, or projected texture is better. Projected_texture. And I'll only just have one input parameter for the end user to point the texture, which will feed into the 3 different projections. So I'll just leave this over here. Next step is that we want to make sure that we have 3 different projections, right? So I think the first projection we've done already is actually aiming towards down the Z-axis, if you look at the compass down here. So I think I'll arrange them for this to be X projection, Y projection and Z projection. So I've already got the Z projection done here actually. So let's go for the X projection, for instance. X projection would be looking down the X-axis, or in this direction, doesn't matter. And you can see that it's or if I change the background color, it's a bit easier to see. You can see that the Z-axis would represent the U and the Y-axis would represent the V. So I want to use Z and Y. So I'll need to actually use a vector construct this time. I got away with not using it here before, but I need it this time. So I needed Z to be my U. Imagine it's saying U and V here for UV coordinates will output this, which grabs the X and Y component I feed. And I'm going to feed it into the UV, so this would represent U and this would represent V. So Z was going to be U and Y was going to be V. And now I'll connect the float 2 into here. And just to see if it works, I can just for now output the results from this texture map instead. And I should have the texture, yep, going this direction. And we have all of this stretching going on as well. But that's the correct results. So now we need the third projection, which is going to be from the top. And for that we'll need the X to be the U direction and the Z to be the V direction. So I'll need another vector construct. I'll copy paste that. I'll place it over here. So I needed the X to be U and the Z to be the V direction. And then I connect this one. Same thing here. I'm going to connect this one just to see the results. And that seems about right. And just to reiterate, the reason I did not need to use a vector construct here is because I can show you. I then need to connect X to X and Y to Y, so just straight across. But I can't just take the combined XY output here instead of deconstructing and then reconstructing in the same order, if you know what I mean. So I think that's about it. There's just one more thing I want to do, and that is add a multiply node here. And the reason we're going to add a multiply node there is that this will let us control the tiling of the texture. So if I just connect the output of the vertex world position into a multiply node, I'll create a new float node, this one, and I'll connect it here. I could have gone ahead and just clicked this value and type in the tiling multiplier, but since I want to expose the value in the end to the end user, I need to use a dedicated float node because this will allow me to expose that value. You could also go for a float 2 or 3 or something if you wanted it to tile in different amounts in different directions, but I want a uniform tiling multiplier. So I'll connect that multiply here. Let's just arrange them like so, for instance, and let's see if this node works. So if I change this value node, which I've got here in my attribute editor, I should get less amount of tiling or more amount of tiling. So if I go down like this, you'll see that it tiles less times than before. And that's the results I want. And this will propagate to all projections since all projections are feeding from the same vertex world position node here. So we're done with the texture projection part, and we can actually go ahead and create a group of this. So I'll just select these nodes, and just to be on the safe side, I think I'll go ahead and save my results here. Alright, so I've saved my results. Let's go ahead and make a group of this. So I'll go group and create group. Now let's see, actually I'll go undo and I'll disconnect this one because I don't want that one, and I'll show you why. I'll select these and go group and create group. Now this group surely works, but I can't get anything into this group or out of this group, and it doesn't really say much what the group is about. So we need to make some edits here. So I can go ahead and just select the group here and just change the name of it, and that is the name here at the top. So I'll call this XYZ-texture projection. And it seems that it does not like the space, so I can go like so, or for instance, yeah, why not? It seems to write it nicely if I type it like this. Okay, so let's go into the group because we need some outputs here as well. So I'll go inside here, and I did use the RGBA before, but I want to use the color outputs because I'm not going to use it for, or actually I could, it doesn't really make that big of a difference, but I'm not going to use the alpha channel from these for anything of value, so therefore I think I'll just stick with the color output. But you can go ahead and use RGBA. It's just a matter of choosing or stripping the alpha channel in the end if you don't want it. So it doesn't really make that big of a difference. It would make a difference if you wanted to use textures with alpha channel, for instance, and use the alpha channel for something. But I'll stick with color, and I'll choose color and color. And make sure you do it in this order. I've deliberately used the X, Y, Z in this order, not Y, X, Z or anything other, because when you have these values listed like here, you always have them in this order, and I think it's good practice to always put them in that order. If you wanted to, you could even go ahead and select these nodes, and just for a nice note for maybe yourself or another person viewing this later on, you could type in a note on this specific node, calling it X projection, for instance, and I could call this one Y projection. There we go. And I'll call this one Z projection. Right, so I'll also want to choose these result outputs and call them something informative, because if I view the group from outside, I'll have the outputs, but they're all called result. So I'll just choose the first one and call this one, let's see, you label it with the active socket label here. So X projection, for instance, Y projection, and Z projection. There we go. That makes a whole lot more sense. So now we've got that worked out, and we need to figure out how we're going to apply the different projections here on the different faces of the model. And as I mentioned before, we're going to use the face normals of the model to decide which projection goes where. And the node you want to use is the vertex world normal, this one. Not the vertex normal, the vertex world normal. And just to show you what that looks like, I'll go ahead and use a vector construct, place it over here. I'll connect the world normal, which is 3 values, into the XYZ here, so they will be used as RGB. And then I'll connect the float 4 into here to pixel color. Now we've got the normals of the faces here, and we've got them both as positive and negative values. So the red we see here, it corresponds to this axis gizmo down here. So this is the X positive direction, and this is the X negative direction. And since it's negative, it's represented with a black color. Any colors that go under 0 are represented with a black color, and over 1 are represented with a white color. So they kind of cap out, if you will. So this is X positive, X negative, Y positive, Y negative, and Z positive and Z negative. And yeah, that's the world normal. And as you can see, as I rotate this around, notice how I've always got green pointing upwards. If I place him like this, I'll still have green pointing upwards and blue pointing straight at me. So it does not follow the model around, it's always aimed in the way the world is aimed. So from here, I think just to make this a bit easier to work with, I want to go ahead and actually use a power of node here and go power of 2. So either a power of and connect this and set 2 here, or just a multiply node and multiply this by itself. Both of those give the same result. So I can go float, for instance. So float, I'll connect this into the Y component, and I'll change this into a 2. There we go. And I'll show you what that looks like, and I'll explain why I want to do this. So if we just look at the visual results of this, we'll see that we've still got this kind of normal color going on, and it's still aligned with the world. But the nice thing about this one is both the positive and the negative sides now have positive values. So you don't have any of these black areas. So if we were to look at the individual channels, for instance a red channel, we'd have white here and black in all the other areas, which works better for us as a mask since we want the X projection to be both on this side and on this side. Another thing to notice, and we can work with is that we've now got a bit sharper transition here between the colors, which is also an effect of this power of operation. Yep, so that works. Next step is you need to ask pretty much two questions here as I see it. You have to ask, is it a X or a Z projection, for instance? And then lastly, is it a Y projection? I have to ask with just two components at the same time. I can't ask with all three, is it X, Y, or Z? And that is because I want to use a linear interpolate mix here at the end. And the linear interpolate takes two projections at a time and mixes by a mask. So that's why I'm going to ask the questions like that. So to start off with, I want to ask, is it a X or a Y, Z projection? And to do that, I want to take the results here and I want to strip out, so I only have the X and the Z value. So I'll have to go for a vector component, like so. And then I want to construct a vector from the X and Z. So I need a vector construct as well. And then use X and Z as Y here. And then I can use this output as my float 2. Now this will be represented as a vector, if you will. That is, imagine that around this circular path, you'd have these surfaces would point outwards. So this one would point outwards this direction, and from here it would point outwards like that. So that's like a 2D vector in that plane, if you will, or in those two directions. So one thing I need to do is, I've got the normalized here, but since I'm stripping away the Z component, this 2D vector won't be normalized. So I need a normalized node. I can show you what that looks like. I connect this in here, and then we can use this and show it as results. And I think I'll go ahead and show it as a result. Sure, let's show it as a result like this. I can connect this one into the XY here. Disconnect this one as this one has priority. It won't show that color, it will show this color. So I disconnect this one. With this node, I will now have something inputting into the X and Y component, but the Z component will be using the uniform float value here. So I want to set that to 0. So this is the results we have now from the normalized results. And if I did not use the normalize and just had a look at the X and Y here, you can see that the red and the green area would not continue all the way up here. So they would fade off as the lean angle goes more upwards. And I want them to continue all the way up here to that point where they meet up, if you will. So I want to use that normalize to get that kind of result. Now this here is going to be the base, as I mentioned, for our decision if it's going to be X or a Z projection. So the next step here is to do a dot operation and compare it with a given direction, for instance positive X. So I know I've used dot operation in a few of my other lessons, but just to explain quickly, I'll do a dot operation and I'll need another float 2 vector. And that float 2 vector, it would be easiest to go for a positive X or negative X, positive Z or negative Z. So let's stick with the first one, positive X. So I'll create a float 2. I want it to be just positive X, so that means 1 and 0. And then I want to compare these vectors with this static vector or uniform vector. And now let's look at the output here and see what that does. So I'll delete this one that I use for visualization, and I'll just connect the X, Y, and Z here to get a black and white representation of that. There you go. Now this is exactly what I need for the first linear interpolation, because this is single channel, just one channel, black and white, and it's black or white, so that works nicely as a mask for a lerp to say where is value A or value B going to be. So we can go ahead and try that out and see what that does for us. So white is going to be the second value in the lerp, and black is going to be the first value. So that means that white is looking down the x-axis. So x projection is going to be the second value, since second value is white color. And let's see, oops, the z direction or z projection is going to be the first value. So this is between x and z, and I should be able to use this, the black and white results here, as my mask for which is going to end up where. So I can go ahead and connect this, and I should now be able to see that it works. It's starting to work, right? We get a nice transition in between here. We get projections from both of these directions. We don't, however, have a projection from the top, which we're going to solve next, which is actually the easier part. This was the more tricky part. So, and I can actually go ahead and just show you what would happen if we did not use the normalize here once again. So if I connect the normalize, skipping the normalize, you would have this kind of result. So the Y would be much more prominent. And I want them to not be as prominent, so therefore I'll connect the normalize there. So next part, and I can go ahead and disconnect these. Not that it matters that much, since the XYZ here has priority, but I don't think it looks that neat, so I'll go ahead and connect it like that. So next is going to be asking the question, is this going to be a Y projection or a XZ projection? So that is, it's going to choose from using the Y projection or from this result we've got here already. So the way we could do that is just taking the Y here and using that as our mask. So just to visualize that, I'll disconnect that and I'll just connect the Y here into the, let's see, X, Y, and Z, right? So X, Y, and Z. So there's my black and white mask, which is going to choose where does the Y projection end up and where does the previous results we had here, the X and the Z projection. So it's pretty much as simple as just using this Y component. So I can go ahead and move this back over here. And now we want to use a second lerp. So I need to create some space here. I'll take another lerp operation. And as you can see, white color represents the areas that we want to have the Y projection on. And as I mentioned earlier, white color or 1.0 is the second value in the lerp. So I'll take my Y projection, connect to the second value, and my previous results from the other lerp into the first value here. And I'll use the Y, which I showed you here earlier, as my mix value. And then go ahead and connect this results here into the XYZ. And we're nearing being finished with the shader here. There's just another tweak I want to show you and then exposing the values. So now we've got the X, Y, and Z projections working and we got them all right, which is nice. We could settle for this. We've got texture and we've got tiling. But I want to show you how to do that transition width or sharpness as well. And that is a matter of, let's see, we can go ahead and delete these since we don't need them. We've got these two masks that are working for us. We've got, hold on, let's just move this around to get a better view. We've got, there we go. So we've got the first mask here, which decides if it's a X or a Z projection, and we've got the Y mask, which decides if it's a Y projection or the combined X-Z projection. And these masks were black and white representations. So what we want to do is the transition between the white and the black area, we want to tighten that or make it wider. And the way you do that is you use a simple contrast method. Or that's one way to do it at least. And to create a simple contrast, you can add by 0.5, then multiply by a contrast factor, the user-driven contrast factor, and then you subtract the 0.5 again and saturate the value if you want to make sure that it's within 0 to 1 scope. So I'll show you. We want to subtract by 0.5. we want to multiply by a given value from the user. We want to add, we need to add back the 0.5 that we subtract here. And then we'll saturate at the end, since we want a value which is between 0 and 1 going into these lerp nodes, or otherwise we'll get some weird results. So let's take this mask for instance and connect it to the first value of the subtract. Then we'll type into this value here, we'll type in 0.5. We'll connect the results here into the multiply, and the second value of the multiply is going to be the contrast factor, and we want the user to set that value. So I'll need to create a float, and that is because I want to expose this as an input parameter later, so I can't just type it in here. So I'll connect that. Then this result goes into the add. Now we need to add back the 0.5 that we subtracted here. So 0.5. And then we'll saturate that result. So we've got a value going from 0.0 to 1 here, and as we subtract 0.5 we change the range in between here, so now it's between minus 0.5 and positive 0.5. And then as you multiply, you will have the values. Let's say you multiply by 3 for instance. I'll change that range from minus 0.5 to positive 0.5 into minus 1.5 and positive 1.5. And then I shift it back by a half. You need to do that to get the midpoint correct. The same amount you shifted here. And then saturate it. And that will give you a contrast solution. So the reason for subtracting 0.5 is you want to use that the center line or whatever you want to call it of 0.0 where it shifts from positive to negative. So from here I could connect this where I had the mask previously, and we'll select this value and see if we get the results we want. So if I now change this, it should work in the sense that as I raise the value it should get sharper. And this is for changing the transition between the Y projection. So as I change this into, let's say 50, I get a sharper transition here. And if I type a really high value, 1000, you should get a really sharp edge. And it seems to be working as we want it to. I showed you this earlier at the start of the video, so I can change this back to 1, which is actually quite wide. I think I'd want something like 5 or 10 or something for this texture, for it to work pretty nicely. So that works nice. I just need to make sure that I have the same contrast solution for the other mask as well. And I think this is a good candidate for creating a group. So I'll go ahead and move this to the side, because I want to have this on the outside, and I'll just select these and create a group. So select them, go group and create group. Select that group and call it an appropriate name, so contrast for instance. And maybe just change one of these input values, because both of them being values is a bit misleading. So I'll leave the first one to be named value, but the second one I'll go ahead and call that contrast factor for instance. I think I needed the underscore, right? Contrast factor. Yep. So now I can just go ahead and copy and paste that group, connect similar into the other mask, and make sure you drive it from the same value here, because now we can go ahead and change this contrast value here, and it will change on both of the transitions. So let's just make sure that works. So select that value. Let's check down here for instance. I should have a seam down here somewhere, and set it to something like 1000. And now you can see you've got these seams here, and it works even where it transitions between the X and the Z projection here. So I can set it back to 10 perhaps. And lastly, I want to just make sure that I'm exposing the variables I want to be able to change later on. So I've got the projected texture, I want the tiling value, and I want the contrast value as well. So select the contrast value, click the expose as material input, set the proper name, so contrast, or actually transition, I think, transition sharpness or width or contrast, but I wanted the keyword transition in there. And the tiling is inside this one here, so I go inside the XYZ texture projection group, select the tiling value here, which is this one, the multiply here after the vertex world position. Click expose as material input and call this one texture underscore tiling. And now as I can just go back to top level. Now as I make sure I have nothing selected, I have these three parameters exposed for the end user. And I think those are the most necessary, or actually the only necessary ones I can figure out from this network. And you should be fine with these. These are the ones I showed you earlier as well. So let's just try another texture for fun. So tiling textures, let's go for the ivy texture again, for instance. We can change the tiling. I can write a bigger number as well if I want. That's way too much for it to be visually appealing, I think. And we've got this transition sharpness as well. You can see it going on around here, I think. Yep. So I think for the ivy, at least when I tried it, I thought it needed a bit sharper transition. And I mean, it's by no means super perfect, but I think you can get away with it in most cases, especially if the user's not looking for a seam. You won't see it unless you really go looking for it, I think. So that's how you create triplanar texturing. And lastly, I showed you these textures earlier on, this one. To create one of these, you go into ShaderFX, you select the node from where you want to create the texture. So you could create the texture from an earlier step if you wanted to. But I do have the results here at the last lerp, for instance, or this vector construct. So I could select this lerp, select so that you've got the preview showing here. Position the camera, and it's not super important, but it's nice. So position the camera so that you frame your object here. Then you can go ahead and right click in this little viewport, hold down the mouse button, right click, and go set swatch geometry. Please also select your camera. Oh yeah, I need to make sure that this one is selected. So select swatch geometry, set swatch geometry. Not sure why this is, it's maybe not throwing me an error, but I don't need to worry about that. So now I've got this texture going on here, which can be nice for preview purposes, since I can see my model here in the viewport. But the thing I want to do now is, when I right click and go tools, you can go save selected swatch to UV unwrapped image. And you need to make sure the node is selected. I know that you can right click even though it's not selected and go like this, and you will only get done, and you can be a bit tricky to figure out what's going on, what's wrong, but you need to make sure that it's selected. Then right click tools and save selected swatches to UV. And you can see that it outputs, oops, I missed it since I right click, but it says here as well. It will give you the path of where that texture is located. I can try it again. So, oops, I'm not doing this right. There we go. Selected, tools, and that option. And it should output the path there. You can see it as previous message, writing swatch, and you get the path for where that texture is located. So, I hope you've enjoyed this shader. Have fun working with ShaderFX. Please let us know what you thought about the video and what you want to see next. To see more, visit our website or follow us on Facebook and Twitter.